Now let's welcome Jeremy, Linda, Lily, and Roshan to the stage.
Welcome everyone to Teaching Voice AI in Motion. As all of you have probably dabbled in the space of LLMs and expanded in prompting there, you all know that when it comes to the voice layer, emotion is a very core part of that. And so with us, we have three amazing panelists that will kind of go into what that really means today. So if each of you want to just quickly introduce yourself, kind of your company, your role, and then we'd love to hear like something that is something about emotional voice agents that is really outstanding and compelling to you today.
Jeremy, I can start. So I'm Jeremy. I lead product at Hume. One thing that is still surprising to me every time I encounter it is when the voice agent knows when to laugh, or when it knows when to kind of give a little sigh, or maybe a really sad or somber tone, like all on its own.
Cool. So I've already introduced myself. My name's Linda, and I'm the head of global business for MiniMax. And I used to be a venture capitalist in the Valley for almost a decade. So if you have any questions about VC's perspective, I'm also happy to answer. And what surprised me is really where AI is just breaking the next frontier. And of course, I'm sure everybody has downloaded Sora, right? And it's actually something we are also working on, which is integrating video and audio together. It's not a voice agent yet, but very quickly it will becoming a real person video conferencing you, and you couldn't tell it's AI. So we'll see that in the next 6 months.
My name's Lily. I'm the CEO and one of the co-founders of Rime Labs. We're training speech models for customer experience. And I would say something that's been most surprising to us in selling to really high volume customer experience teams that are powering, right, like 1 million calls a day, for example, is the voice agent driving something like, 20% of all people who are calling these voice agents are saying thank you before being transferred to a human agent. And so that for me is huge. Like, what is going into that 20%? I'm not exactly sure, but people are feeling like, it's the same reason I guess you type in thank you when you're talking to ChatGPT, but no one was doing that for the IVR systems of 2 years ago. So that's the sum total of the experience that leads 20% of people to say thank you is the same thing that's gonna mean that 100% of people say thank you in the future. So that's really what's surprising and exciting to me.
Amazing, thank you. And I think Lily kind of fed right into us going back 2 years ago into what was a voice call with like a robot 2 years ago, where you'd call, let's say Verizon, you answer and you just immediately hear that voice of like a robotic hello. And I don't know about you guys, but for me, I immediately just hit 0, or I'm saying representative over and over again until like I get to that human agent. And then, obviously the world of AI has developed so much the past 2 years. And Hume just yesterday released a new model. And so Jeremy, if you want to kind of dig us into a little bit of that progress that we've seen over the last 2 years in terms of where voice AI is today.
Yeah, the progress in the past 2 years has been pretty crazy. Hume released their first voice model, EV1, about 1.5 years ago. And to see where we came from that, which was like, maybe a little bit robotic, with not very smart intelligence, run by maybe a smaller language model, and to see what we can do now with frontier models running voice agents in the background is pretty crazy. You can have something like a Claude 4.5 Sonnet or a GPT-5 run a voice agent, and maybe like a little bit slow, but it is a fully seamless real-time experience. So going from Siri, which we all still have on our phones, to kind of early voice models to what we have today has been pretty breathtaking.
Absolutely. And we're in a room of like developers, builders. Linda, if you want to speak to a little bit of when everyone's building and like building for business, what does that mean in terms of building an emotionally intelligent agent? Like what's really at stake there?
Yeah, it comes down to dollars, right? Whether we talk about fancy technology or not, it really comes down to the real business impact. Give you an example. So we are working with some of the largest, traditional platforms when it comes to call center. And in the past, if you don't have the right audio model, it will either be very robotic, people don't like it, or in even worse case, it will be having the wrong emotion. For example, in an insurance client we've worked with, and the person who's calling in just said, hey, I got hit by a car. And then the voice from the voice agent was not sympathetic at all, right? It was like, oh, I'm sorry to hear that, and then moved on. It was even like worse than not having any emotion. So having the right emotion, having the right context is very important. And another example I will give is we were actually never surprised by people saying thank you to voice agent, because we also built one of our very popular app with 150 million users globally called Talkie. And from the name, you can tell it talks. And the average time spent on people talking with our voice agents or characters is about 90 minutes per person. So that really speaks to, hey, if you have the voice right, have the characteristics right, have the authenticity, you will have a very engaging customer base. So that's the two examples I will be giving.
And kind of digging into those characteristics, that we have so many different dimensions of emotion. And Jeremy, if you want to go into I know there's, I believe, 27 that you guys talk about at Hume, what that intersection really looks like.
Yeah, I think Hume's kind of early research was around semantic space theory, which is the theory that when you have emotions, you don't necessarily have to be one emotion or another emotion. Right? You don't have to be disappointed or sad. You can be a combination of both. And so instead of representing emotion as a binary, say maybe you are disappointed or you aren't disappointed, you can actually represent it more on a sliding scale. So you could be a little bit disappointed and a little bit sad, both at the same time. And so it really is like a multi-dimensional plane where, kind of in an embedding space, everything can be clustered. So you can have disappointed and sad right here, but right in the middle you can have disappointed and sad. And there are different emotions that are all kind of subsets of others that you can see on an embedding plot. And I think Hume's research has largely focused on centering on 48 different emotions and making sure that our voice models know how to differentiate when a user uses one emotion versus another, and also capturing that subtlety. So when a agent sees a mixture of a couple emotions, maybe it'll respond differently than if it's just seeing that the user is 100% disappointed.
Absolutely. And Lily, because of all these different types of emotions and the cross-reference between all of them, and I know at Rime you guys focus a lot on the authenticity of that speech synthesis. Could you elaborate a little bit about what happens if the model gets it wrong, and how the negative impact that it could, or the catastrophic impact that it could go down?
I mean, I think if someone is, it depends on the use case, right? If someone's really hungry and they're calling Domino's, maybe the barrier to entry or the tolerance for weirdness is higher. But if you're calling, right, and again, in an insurance claim scenario or in a healthcare scenario, something's wrong and the bot sounds sarcastic, I mean, it affects not just the success of that one call, but the total. I mean, again, what is the definition of customer experience? Customer experience is the sum total of your impressions as regards to your experience with a brand. And so if you're saying, I'm in desperate pain because I have this injury, and the voice agent says, not just neutrally, but positively, oh, I'm so sorry to hear that, it can be, that's catastrophic, right? And I think at the same time, right, people think that this is rocket science. I think it's hard to wrap your head around what emotion and voice AI means, and I don't think it's rocket science. I think people want to feel heard. People want to feel when they're going down the happy path in the interaction that things are going well. When they share information that has a negative valence, that the bot responds appropriately so that they feel like they're being listened to. And that's not just the quality of the emotion, right? One of the reasons why we've focused on collecting one of the largest proprietary data sets of people talking to one another, so conversational speech, is because when you call Verizon, it should sound like someone that could be working at Verizon, or that could be your friend or family member. And the focus on I don't know, everyone knows there's 100 reasons when you call Verizon that like your cortisol is going to be high, right? And so like it's our job as trainers of models, collectors of data, and as developers to figure out what those 100 reasons are and, you know, make them 50 tomorrow.
Absolutely. No, I love that. And kind of, you know, we talked a little bit about like the why aspect of voice. I want to dig a little bit with each of you about the what and like how you're getting there. Jeremy, if you want to kind of kick us off here about with like Hume's empathetic model, like how does that work? How are you, you know, approaching like observing and then also then responding back with emotion?
Yeah, so you know, at Hume we kind of have two different layers of emotion. The first layer of emotion is in the user speech, right? And within user speech, there's two components. One, we want to be able to capture the user speech in an accurate manner. So for us, that looks like tokenization. How can we represent human speech in audio tokens, and how can we do that such that we capture all of the nuance in the user speech? And then separately, you know, in our conversational AI models, so EV3 and EV4 Mini, which we just released yesterday, we have expression measurements. So what that means is that every time you look at the chat history, or even during the conversation, you can see what are the top 3 emotions that are present in the user's speech. And you know, that may not seem, you know, anything indicative, but especially when you analyze over, you know, tens or hundreds or thousands of calls, you can start to notice patterns in kind of how the emotion is captured and how that relates to your use case, which you can then use for evaluations. You know, we've seen that when you evaluate with expression measurements, you get 15% higher accuracy of evals compared to just traditional text transcription evaluations. So I think there's a lot of really cool components, both in the measurement space, both on during calls and then after calls, and then even on the reproduction space. By capturing human speech with rich tokens, you can also output those audio tokens. So the same nuance that's captured in the initial, you know, speech that the user says, the model can also kind of respond with the same richness. So you're able to get like tons of nuance and, you know, borderline realistic speech. There's been a lot of times when, especially recently, when I've been listening to our models that are in development, and I listen to a voice clone beforehand, and I listen to the voice clone after, and I could really only tell the difference because I've been working on it for the past year. So I think, especially when I show people clips before and after, I think people are really surprised at where the space is heading and how much really rich and emotional nuance can be captured.
Thank you for that. Lily, I'm really curious as like another lab, like, you know, how does that, your approach at Rime, like, how is it similar, how is it different? If you want to dig into that.
I think there's a general approach in speech modeling, borrowing from text language modeling to scrape and purchase as much data as is humanly possible, and then train a self-supervised model to predict tokens. Of course, when you're training a text-to-speech model, that's predicting audio tokens given text tokens. If you're training a speech-to-speech model, that's predicting speech tokens given speech tokens. And I think what people forget is that you're losing some of the control that comes with training more traditional text-to-speech models. And what I mean by that, right, is like emotion is one part, but imagine if you're saying, okay, so just as an example, there's a huge hotel chain. They know that as part of their voice agent, if they say the person who's calling's name, so if they say, right, like, hey, thanks for calling Lily, that I would be 20% more likely to book a room. Okay, but what if they don't know how to pronounce the word Lily, right? Like, and so there's a multifaceted aspect to relatability. It's one thing if you nail all the emotion. It's another thing if you like can't pronounce the person's name. And so it has to be tackled from every angle. I'd say one of the things that we're doing really uniquely is building highly expressive models using similar approaches, right? Like with large language model backbones, but given a level of customizability that you could count on the consistency of pronunciation being there every single time, and then building tooling around the model so that you know, okay, like this is a name that Rime isn't 100% confident that they're going to pronounce correctly. We're not going to say like, hey, thanks for calling, right, so-and-so. So, I don't know, you have to tackle it from every angle. I guess that's my answer, is like every single angle is really important.
Absolutely. And so, Linda, I'm curious, MiniMax, you guys, have 30 plus different languages, you're globally present. How do you, like in a very similar light, like how are you looking at this in terms of like the cultural implications there?
Yeah, before cultural, let me talk about the business terms, right? Because a lot of people think, the frontier of voice model is this rocket science. It's not. And for any of you, the evaluation is very easy, right? We work with all the top leading companies, and everybody's doing eval in a, double-blinded fashion, right? You put in a couple text-to-speech models, and you listen to the voices in your script, in your use case. If it's language learning, you are teaching Japanese in English, right? You do code switching, like for example, as simple as that. And you will be able to immediately tell which text-to-speech model is better just by these couple categories. So number one is how human-like, how natural it is, right? Number two is how accurate it is, whether it's normalization, like can you read structured phone data correct? You will be surprised if you put in the text, most of the text-to-speech language models will fail. And then number three is, can you do the accents correctly, emotions correctly? Number four is all the additional features like voice cloning, multi-language, code switching, et cetera, et cetera. If you put these categories together, the text-to-speech models that can actually survive is like less than single digit. And plus, if you put performance metric like latency, for example, MiniMax model on Vapi right now is 175 milliseconds. It's faster than most providers. Plus, all these 4 performance metrics were all check the boxes and top grade performance. That's almost an impossible triangle or whatever shape you call it. So that's where actually day-to-day, like a business enterprise are evaluating everything on. So I know a lot of people here are developers. If you're developing an application that's leveraging voice technology, you should keep those very first principle, like a mundane thinking in mind. That's the ultimate eval you need to get through for any text-to-speech model. And then coming to the question about multicultural, multi-language, it's super like underrepresented globally, right? So for us as a lab that has an international angle, we know how even some of the best models like OpenAI's model or Google's model can get like Asian language pronunciation only 85% there, right? It's always a little bit weird. It always never sounds local. And that's something we are trying to fix. It's the last mile problem to make the frontier voice model available for all different cultures and respect the culture, respect the local accents. And as a way of continuing that culture, it's the little thing we could do for humanity here. Yeah.
Thank you. And so I'm curious from each of you, we've seen tremendous progress the past couple of years. And you guys are obviously at the forefront of this. What do you feel like is the biggest unlock that would get us to like the next wave of what it means to be an emotionally intelligent like voice agent? If each of you wants to take a stab.
Yeah, I think from a technical side, there's a couple challenges that I think both of them have talked very much about, and we all share very, very similar challenges. I think 2 main challenges that come to mind. The first one is reinforcement learning. So actually being able to collect human preference and understand what people want out of a model. So as it comes to pronunciation, as it comes to accents, there is really high-level decisions that also need to be made, such as when you create a voice that speaks Japanese and you have it speak a different language. Obviously, we'll be able to do it fluently, but the question is, do you retain the accent of the traditional speaker? So if you have like a Japanese speaking sample, do you want it to speak with a Japanese accent speaking English, or do you want it to speak fluent English? So I think there's a lot of high-level reinforcement learning decisions that have to be made in order for models to succeed. And I think that kind of stems into emotional reproduction because you have to make active decisions against whether to support more emotional voice or whether to support maybe more monotone but more stable voice. And even getting to that perfect medium is still something that everyone's trying to do. And separately, I think, as Linda mentioned, normalization is a really big thing. Each speech model can only understand, like, I guess that based off of the text synthetic data that's used to understand text inputs. And that, I guess, can kind of stem into user data or whatever the company is doing to get to those portions. But knowing how each model and what each model's strength is also, I think, going to be very important to people making decisions. For example, some combination of characters, like maybe colons, throw some model off. Maybe semicolons throw some model off. Maybe some model can't have more than like 2 sentences per request. I think there's a lot of different limitations, and when you have a script that you might want to test out, you might want to kind of address each of these problems as you get to them.
Okay, so for me, we are a slightly different sort of model builder because we focus on all different modalities, right? Whether it's text, video, and audio. So what we are looking at are 2 problems. Whether the first one is how grounded you are, right? And again, as I mentioned, in the real business case, it's all about that last mile problem in the voice model. Like, is your voice model stable? Does it hallucinate? Does it pronounce all the normalization correctly, etc.? So that is a very, just basic work, but to get it right to the enterprise level is actually surprisingly nobody's there yet, right? The best model is actually Microsoft Azure, right, which came from like a decade ago or something. But then we are trying to add human emotion to this latest version of iteration using transformer, using auto regression model, but with all the accuracy that comes from the old traditional like text-to-speech model. But that's at the groundwork level. However, the other metaphor I will be using is to reaching for the sky. Think what's really coming next. And there's a big thing coming next, which is multimodality fusion. And that's what everyone's working on, like the top labs are working on. Like, for example, Sora 2 is a video model, but what makes that video model great is actually the audio. Right? If you notice the audio and Sam Altman could be speaking in different languages using very distinctively his voice. And if you think about the dimension, voice is just one dimension, and everything we perceive with human brain comes in different dimensions, right? And if you are capturing somebody's emotion, that's not only expressed in the voice itself, but also the facial expression at the time of the person speaking. So what we are also working on is multimodality input and multimodality output, and very rich captioning on not only the voice data, but also everything else, the text, the facial expression, the video, etc., and even the background noise, right? So everything, what we are gonna be looking at in the next 6 months, the most frontier labs are gonna be doing multimodality fusion model, and that's something to watch out for.
I think the most important thing to remember when we think about voice is that the way that I'm speaking right now in this panel is not how I would be speaking if I was at the booth and you met me, and it's not how I would be speaking if I was a customer support representative for Verizon, and it's not how I would be speaking if I was giving a talk, right? It's not how I would be speaking if I was having a sales conversation. And so I think what is truly exciting about modeling is that for the first time, there's going to be models for very particular things, right? Like, there's going to be speech generation models that are very good at generating influencer accent, right? Like, there's going to be speech models that are very good for, again, multimodal narration over video generation. And by the way, I don't know if you noticed this, but like the way that people talk in TikTok videos is very different than the way that they talk, right, when they're on a phone call. Goes without saying. And I think that's what's truly exciting is that, like, for the first time, people are building models that look very different, right, and that have different capabilities. And so, I don't know, it's one thing to look at stats, right? It's another thing to be like, what can I do with this model? And versus like, what can I do with this model? And that to me is truly impressive, because if I put my business hat on, I say, like, we're at an inflection point where the total addressable market for voice AI is like 1% of 1% of what it's going to be in 20 years, and if not less, then it only stands to reason that, like, there's going to be use cases that we can't even imagine today. So I think we should remember that too. And by the way, like the emotion we experience when we watch a TikTok video is very different from the emotion that we want to feel when we are talking to a customer support representative.
Absolutely. And I think that feeds right into my next question of, what are the use cases that you guys are seeing today where it's almost like an unexpected adoption of people incorporating very emotional agents?
Yeah, I think actually there's two that I can think of that I've been very surprised by, especially the past 6 months. First one would be gaming. I think that now finally text-to-speech and voice agents are getting cheap enough so that people in gaming feel like they want to support like customized and individualized experiences for some of their higher paying customers. For example, some games we work with may have like subscription plans, and then the higher subscription plans may get access to voice-first experiences within their game. And so that's something I'm super excited about, and that's something definitely emerging over the next, I think, 6 months. I think media and entertainment is another really big case. I think there are lots of big companies, think maybe your NBC Universal, that makes movies, makes ads. I think lots of those kind of text-to-speech use cases will also start emerging. I think Hollywood has finally started deciding that they're going to adopt AI. And so I think that is also something we're going to see. I think maybe AI-generated ads, especially from larger companies, and AI-generated TV shows might also be non-agent, but still voice AI use cases that might emerge in the next couple months.
Very cool. Yeah, and I know from like the Vapi side, we see surprisingly a lot of adoption in like healthcare spaces. And everyone used to always say like healthcare is going to be the last industry to leverage any sort of AI. And the number of calls I've been on of customers being like, I want not just a voice agent, but one that is really understanding the patients and understanding like how they feel throughout every part of like even just a simple use case as like appointment scheduling. And so yeah, I completely concur.
I think to add to that, even companions are becoming really big, especially emotionally aware companions. AI therapy is doing really well on the App Store. There are a lot of use cases that I think within healthcare people will start to pick up as well.
Absolutely. And then before we open up to Q&A, I'm curious, Lily, for devs, what considerations do you feel like developers really need to be focusing on when trying to like start off with implementing more emotionally intelligent voice agents?
I think building a voice application is not different, although it feels different. And maybe this is just because we're all in the era of vibe coding, but like it shouldn't be different than building any other application, and that you think about. I'm not saying you're not going to be surprised about how people use the application. That's like the best part about building. But generally, people should think about what they're trying to accomplish with an application. What do they want users to be able to do? And I don't know. I typically think like when people are disappointed in AI, it's because they haven't, like voice AI in particular, and building an application from prototype into production, it's because they haven't thought about what they want it to do and what they want the experience to be like. And by the way, like for the first time, you're able to design a voice experience, real-time voice experience, in a way that you were never able to before, right? And so, I don't know. To be perfectly frank, like typically we're selling to, people have had existing voice application in production for 20 years, and in many ways they're the ones that are most excited, right? Because they've seen where technology has been, they see where it is today, and they think, this is the first time that I feel like I'm able to build something. And I think like people who are new to voice AI forget that how impressive that must be to be working on something for the entirety of your career, and for the first time something feels possible that wasn't before. And so I would also just look to people who have been building these voice applications for a long time and figure out like what are they most excited about. I think it's often really worth learning from people who've been in the trenches. And at the same time, right, like people who are doing things like in companionship and in net new use cases that are completely apart from like prototypical customer experience, like there's a lot to learn across the board. There's a lot to learn.
Amazing. Thank you. So I know we have a few minutes, so definitely want to wow, the room has just grown. So definitely want to open it up to a few people in the audience if there are any questions to our panelists. I saw a hand over there.
Hi everyone. So when you use the text-to-speech engine, which are different companies, can you include something in the text to tell them what kind of emotion you want, something like SSML, and you guys work together to standardize that such that I can switch between TTS provider and use the same difference?
Whoever wants.
Yeah, I can start. I think actually at Hume we've had a little bit of a different approach. Besides pauses, we've kind of made the decision for at least our existing models that we want the model to decide what's best based off of the context. So you provide the context to the model. So not only what you're trying to generate with text-to-speech, but also maybe some of the previous passages that are related to the same conversation or related to the same passage. And then the model will be able to figure out how to best respond, what tone to use, whether to laugh, whether to keep it stern. I think also related to the voice that you pick. If you pick obviously a more emotive voice, it will maybe tend to also throw in laughs more into a speech than if you use a more kind of assistant voice, which you wouldn't necessarily want casual laughs. So I think pauses is one component that you can't really do that with. So definitely controllability of pauses, and SSML has been popular, but I think a lot of text-to-speech companies have also just done in brackets pause, and that seems to work pretty well for some people. So I think there's been a kind of mix there.
Yeah. I will add to that. So if you try out different models, of course, there's an industry-leading model where they allow you to put in any kind of natural language describe like emotion. We're working on something similar called instruction mode, but we also have you can, for a drop-down, choose certain overlaying emotion. So different people are doing it differently, but I agree with Jeremy. The trend of the industry should be you express everything in natural language, right? You are almost like a director. You tell your crew how to perform, right? These are your voice actors and actresses. That should be the ultimate state. And when we are interviewing people, ultimately they were like, we just want your the voice to represent the emotion of the context instead of giving every nuance instruction. Where we will give the controllability when you really want to enforce certain emotion, right? Whether it's a sad text, but you want the person to be laughing while talking about that sad text, that's a special case. Otherwise, it should be the model should be the best performer you can get, and that's our approach. And we also have a eval set that has different emotions across different TTS models. If you are interested, happy to share at our booth after this. Yeah.
Thank you. Go to the next question. Sorry.
Basically following on that, I'm seeing that similarly to your point, Jeremy, the real value is when you have that context. When we're using these cascading models, where oftentimes the text-to-speech is getting this isolated string, and it feels to me like that's holding a lot of folks back. I feel like I don't have a full understanding. That's put so much time into our stack, and I feel like our AI is responding well, but I feel like I'm totally missing how to really give emotion to our agent, which is a coaching agent, so it's really important. So I'm just curious, partly how Vapi fits into this, and how these orchestration layers, or how you all feel like you're being held back at that position in the stack at the very end where you're speaking, because that is just so valuable. And obviously our master prompt explains how the agent should act generally, but that doesn't mean things can't get exciting or things can't get dire. So I'm just curious, how you're addressing that limitation on the industry is moving forward with it, so that you're doing this great training, but we're not providing the context to really utilize it. Or maybe we are, and I just don't know.
Yeah, I think at least on our side, we let you put in previous basically requests or the text that you've generated previously, usually request ID. And so you can store those after generations. Either put those back into the request, you can just use a variable. So yeah, but I think that's a very new thing. I don't think there are many models that let you force inject context, but I definitely do see it coming to more and more models lately. Yeah, I don't know about you guys, but that's how we do it.
Yeah, we are starting to allow people to pass certain parameters, emotional parameters. So it kind of is intermediary way of solving your problem, right? So you will understand the context on your end, on the large language model end, and pass that emotional parameter for that next sentence, right? And into our model, it will be able to act accordingly. Yeah.
At least how I'm thinking about this is like, ideally, the text-to-speech model would operate in the same way that the text language model does, and that it sees it has context, right? And I think what you're going to see in the next 12 months is reasoning models, that is text language models, that are also generating audio tokens in parallel. And in that way, by the way, the data for these kinds of models has yet to be collected. I don't think people realize, like, how are you going to model a conversation where the first half of it is something that's good is happening? I don't know, something good is happening, exciting, right? And then something turns less good. You're going to have to collect really rich duplex data. And you can't use synthetic data to do this because the same reason you just mentioned, right? Like text-speech models lack context. So if you're using a text-speech model to generate like duplex data, it's not going to work. And so like there's going to be a huge data effort required to train a model that has the previous text context for a conversation and then is generating, again, text, but in parallel audio tokens. And to my mind, that's probably the only way to solve this problem today.
Thank you. I'm going to take one more question from this side. Anyone has a question here? Oh, yes.
Yeah, just ran some research on like the healthcare use case that you were actually talking about with voice AI, and I think what's interesting is like people in that work, at least people were fine talking to robots. I think like, you know, we can make systems that people think aren't human, but eventually like they want to know they're talking to robots, they're fine talking to robots. And like they want it to be kind and to do this emotional matching, but at the same time they tend to want to reject like this fake empathy, since it is a machine who didn't have those experiences or can't like imagine those experiences. I'm just curious in your experiences with much more volume, like how people have been interacting with like, oh, I know how that can feel, versus
Right.
like, I'm sorry you feel that way.
I can speak to this pretty directly because we built what we call a it's really a bad name, and we need to rename it. But as part of our piloting, we often have people report the success of calls to us, their voice AI calls, and we have users who have, I would say, like hijacked that API that we built to report call success as part of our piloting to A/B test different voices in production. And what I think, and this is, by the way, like I don't know if this is cross-cultural. It probably is. It might be just true of the United States, but I guarantee you, if you were to find the highest likelihood rhyme voice in a drive-through context, for example, it would be one of the least emotional voices you would ever hear from a TTS model. And we find this across the board in tech support, and in many cases in healthcare too, right? Like the most downbeat voices are the ones that people feel like they can open up to the most, because it doesn't feel like totally phony. I don't know if that is that kind of in line with.
Yeah, no, that'd be nice.
We find this across the board, and you would be shocked to hear like top performing voices in really high volume use cases.
I would add, sorry, real quick. I would add to that as well, like the use case we've built out for customers, like anytime we've made the assistant slightly more emotional, they're like, it's too much.
Yeah.
Our patients don't like it. Like, tone it down. Jeremy, but
Yeah, I think that all does actually rope into the idea that, you know, it's not a one voice fits all market, and it's never going to be. What you want in, for example, an AI therapy companion is not going to be what you want when you're trying to get help with your insurance. I think the major thing that we can start to see, at least within healthcare, is probably just smarter like assistants, rather than, you know, trying to get the voice agent to seem like it's truly empathizing with the user. I think ultimately, like in modeling, one of the questions that you can kind of get to is, are models actually empathetic, or do they just learn empathy? But I think also that's a larger question, because how do humans learn empathy? Do we learn empathy because we see people being empathetic and decide like, oh, this is like the proper thing to do, this is the respectful thing to do, this is what I'm going to do too? So I think from also a philosophical point of view, it's very interesting because models might be learning in the same way that humans learn, but we don't have like definitive proof either way. So still very unclear whether it's simulated empathy or just reproduction of empathy, kind of how humans do.
I know we had one question here.
Voice AI agent for human resources team, which needs more empathy. So, for example, employees calling the human resources agent to report about staying anonymously reporting about fraud, waste, abuse kind of issues. We have never seen anybody doing agent for this. So we are struggling really. Right now we are using 11 labs. We are struggling the agent to be emotional, as somebody said. That is first. And the second one, we are finding the agent to kind of understand the tonality and the kind of the sentiment and the stress level of the other person calling, and based on which the responses can be tuned. So we are struggling on both aspects. I think this emotional aspect is very crucial for our use case. So I want to understand what you guys are doing with respect to your building.
Yeah, I can take on that. So there's part of understanding the context, the emotion, like when a person is calling in and what situation, are they emotionally stressed, etc. So that's like one argument for the speech-to-speech model where you have really rich context. But of course, like on VAPI and what we are building here on this panel are more the cascading model, right? And it is true you are losing a lot of those contexts, even at the transcription stage, right? Where the current transcribing models are mostly just writing down the text instead of inferring all the other additional information. So that's part of course, the speech-to-speech technologies people are working on is trying to tackle that. But for the amount of small information you retain just based on the text, you can also infer certain kind of emotional state. But then I think the three of us are better versed to answer the second part, which is when you have certain response and you want to pick the right emotion to speak to the person. I just want to add on to this, like it's an unsolved mystery to me. Like there are certain voices just act super well in certain use cases, and you will never know why, right? Sometimes it's like, for example, for the VAPI voice, like Jordan's voice, right, which is codenamed Elliot on the VAPI website. It's by far the most popular voice. Like nobody knows why. So what I will suggest is to use the model that can clone different voices or design different voices and iterate in your particular context and collect data. That's how models are learning. That's how we are learning without predetermining which voice might work the best in your context and for your employees. That's my very practical answer on that.
Lily or Jeremy?
I would give similar advice. I think a speech-to-speech model, for example, we have two speech-to-speech models. We have EV3, which is a larger speech-to-speech model. The benefit of that is that it can understand, the user's tone and context. And we also have like our emotional measurements that come with our speech-to-speech models. We basically just take the user tokens and then gain those insights from both of them. And EV4 Mini, which we just launched yesterday, those will probably give you the most rich expression and understanding of the person's cadence, of how that ropes back into your overall prompt. But then, yeah, I think voice is very important on the reproduction side towards making sure that the model acts like it understands the person. So definitely lots of prototyping needed there.
Cool. Thank you, everyone. I know we're a little over time, but thank you, everyone, for kind of coming to Teaching Voice AI Emotion. Thank you, Jeremy, Linda, and Lily, for the amazing context that we've had here. I think we're headed into a future where you're not just sounding human-like, but actually having every caller feel heard on every call. So thank you all, and thank you to our amazing panelists.
Thank you.
Thank you.
Thank you, guys.
Thanks so much.
Thank you.